Well, happy Monday, October 24, one week from, I was going to say Thanksgiving, no, Halloween. Thanksgiving's in like a few more weeks. And then before you know it, the end of the quarter. Okay. Well, we're still talking about pandas. We're going to be talking about, we'll talk about pandas on Wednesdays too. There's a lot going on, but again, pandas is the package that we use that allows us to work with data frames. Data frames are these table-like structures where we have different columns. Columns are each NumPy arrays. Each of these arrays have the same data type. And then, and we can work with them. All right. Now, one thing that separates pandas from, say, R, even though both of them have these data frame structures, is that pandas, all of the things have a index argument. Okay, so the columns are stored in structures called series, and the series will have an index. Okay, so here I have created two series, and I'm calling them original 1 and original 2. And I want you to note that, and the values in original 1 are 1.4, 2.3, 3.1, 4.2. So these are in order from least to greatest, okay? And as far as the index goes D, C, A, B. So the index is not in order, and just to kind of make sense of this, so is that the value after the decimal point, the 0.4 corresponds to the D, the 0.3 corresponds to the C, the 0.1 corresponds to the A, and the 0.2 corresponds to the B. So this is in order from least to greatest, 1, 2, 3, 4, the values before the point, and then the values after the point correspond to kind of the index value. Just so you can see, because I'm going to be doing things based on the index, based on the value and stuff like that, and just so you can kind of follow along or without having to like do too much mental gymnastics here to go here. Okay, we have series 2, something similar. The 0.2 goes with B, the 0.1 goes with A, the 0.3 goes with C, and the 0.4 goes with D. But this is in a different order, and they are not sorted from least to greatest or anything like that. So this is 2.2, 3.1, 1.3, and 4.4. Okay, so when you create a series, the order of the index and the order of the values, okay, is preserved. So this goes D, C, A, and B, all right? And I didn't print out original 2, but you'll see that it would go in the order B, A, C, D, okay? But what I'm gonna do is I'm gonna put these two together into a data frame. So I'm gonna have data frame, and here I'm using a dictionary to kind of create it. And so the variable name is gonna be X, and the values in that variable X will be the values in the series original 1, and then the values in variable X2 will be original 1 multiplied by 2. So we are using, okay, so here I've got two series that have the same series order, DCAB, right? Original 1 has the index DCAB, and original 1, I'm just multiplying it by 2, will also have the index order DCAB. And so when I make this will have DCAB as the index order, okay? Here, original 2, index is BACD, and here I'm going to create another data frame where I take original 1 as variable X and original 2 as variable Y. Series 1, original 1 series, DCAB, and series original 2 have different orders. This has index BACD. So these two series, their indexes are not in the same order. So what pandas will do is it will sort the series, the series by index, and then join them together. Okay, so here we're going to get ABCD and ABCD, and so you can see that both of these now have 0.1, 0.2, 0.3, 0.4, and 0.1, 0.2, 0.3, and 0.4. Okay, so but the values are preserved indeed. Okay, if you ask what is the index, you get an index object, which is kind of like a tuple. And if you say slice, okay, if you slice the series based on the index, it's going to use the order of the index, right? So it goes D, C, A, D through A. It's going to slice out these values according to this, not according to, say, this data frame where D is the last row and A is the first row or something like that, okay? Whereas over here, if you ask what is the index of the data frame, the index of the data frame is A, B, C, D, and when you slice the data frame, naturally it will use the order of the data frame's index, A, B, C. So it's going to go, it's basically slicing A through C here, which is, you know, different from, say, any of the individual indexes, okay? So sometimes, a lot of times, your data frame index is the same as your series index, okay? Because a lot of times you start off, you know, you import data and you create a data frame, and then you extract some of those columns as series. And so in that case, your data frame index is in an order and your series index is in an order. And so you kind of somehow in your brain you think, okay, the data frame and the series and these indexes behave the same and stuff like that. But that's actually not true, is that they are handled in different, slightly different ways. If both the data frame and the series have the identical indexes, then they're going to behave the same. Okay, and I would say that's probably most of your cases. That's most of your cases, because your most frequent way with working with data is you have some CSV file and you import it, and that creates your data frame. And then if you're working with a series, you're gonna just extract out the column, and that's fine. But these kind of examples here are just to kind of remind you that the series and the data frame are not necessarily going to have the same index order, and they do behave differently. And sometimes, you know, as you're working, it's easy to kind of get confused. And if things aren't behaving the way you expect them to, then it could be because their index orders could be different or something like that. So just something to keep in mind. Again, probably 95 times out of 100, the index of your series and data frame will be the same. But that's what you have. Okay. You got sort methods. So here is our series, and we can say here is okay. So the series is BACD, and you can sort the series based on the index. So you just call you know, series name dot sort index, and this does exactly what you want, ABCD. Or you can say take your series and sort them by value, right? By value, you know, in order, numeric value, right? 1, 2, 3, 4, you know, as far as the leading values go. So those things exist for a series. For a data frame, again, I guess your data frame doesn't necessarily might not be in sorted index, might not be sorted by index value, but here I'm going to do df. Here's my data frame, and you can say, you know, I want to sort by one of these columns, right? So you say sort the values by, say, by x, and then you have a optional argument, ascending equals false, and now we've sorted the data frame by x in descending order. So I think, you know, I think this makes sense. I think, let me see, if I take this, so the result of this is also data frame, so I think I can do so you can, you know, this would be stupid, right, to sort values and then sort by index later or something. But basically, if you do have a data frame and the result of that data frame isn't sorted by index or something, and you want to sort index, you do have the sort index method, okay? But this would be dumb because the sort index would just cancel out the sort values. But basically, anytime you have some kind of method, right, and the result of this method is a data frame, you can just continue to chain methods, right? After the data frame returns sort values, basically all of the same data frame methods are available, and you can chain another thing, whether it's, I don't know, pivot this or that. So those are options. Okay, what if you want to change the index? Okay, well, the index of a data frame or series is immutable. You cannot just go around and modify the index, okay? But that's not to say you can't change the index. You can take the index attribute of a data frame and just reassign it an entirely new object, okay? So, for example, like a list is mutable. You can take a currently existing list, right? So you have the name, L1, and it's pointing to this object in memory, and you can actually modify this object in memory from, appending an object or, popping a value or something like that. You can actually change that, okay? Whereas a tuple, if you have, some object name T1 and it's pointing to an object in memory and it's this tuple, you cannot change this tuple. If you want the T1 to be something different, you have to create a new tuple, and then you have that name T1 point to the new tuple. You can't take the old tuple and modify it. You just have to create an entirely new one, and you just have that name point there. Okay. Similarly, as far as pandas data frames and their indexes, the indexes are immutable. You can't take that object, those values, and change them to something else. But if you want to change it, you can create an entirely new thing that's going to be an index, and then you just say, all right, use this new thing as your index, okay? And so that's fine. So here, original one. So original one's index is DCAB, and here I'm going to just take an original one, or the values originally are 1, 2, 3, 4. Here I'm going to just say, all right, take the index of original one, and let's just replace it with a range 4 object, okay? And now if I ask what is original 1, okay, those values are in the exact same order that they first appeared, 1, 2, 3, 4, and then now the index is 0, 1, 2, 3, okay? We didn't change the index per se, but we just created a new object and we assigned it to be the index of this series, okay? So here we have this, and if you ask what is the index of original 1, it'll say range index, okay? Range index. And now, all right, original 1, and if I do square bracket 1, what is this going to pull out? It's going to pull out the value 2.3, okay? And if I do location square bracket 1, location square bracket 1 pulls out the value associated with the index, also 2.3. And then iloc will also pull out 2.3 because, well, the location is same as the zero-based index location. So iloc always uses a zero-based index thing, and it will pull out, zero-based index 1. And so, in all three cases, these things do the same thing. Okay, .loc and just doing square brackets have the same behavior on series. Okay, but if I say, all right, let's just, again, we're going to create an entirely new object. Here, it's a range 1, 5 object, and I'm going to take this range 1, 5, which starts at 1, ends at 4, and we're going to assign it to the index of the thing. So now this is 1, 2, 3, 4. Okay, original 1, what is this going to pull out? This will pull out 1.4. Whoops. This pulls out 1.4. This pulls out 1.4. But iLocation 1 is going to pull out zero-based index, so it's going to pull out 2.3. Okay. If I say, okay, what is square bracket A? This throws an error. This doesn't exist anymore, right? We no longer have this key as far as the series index goes. Okay, it was when we first defined our series way back here. Sure, this would have pulled out 3.1, but we've thrown away that old index so that we no longer have ABCD. Okay, so if I want this back, okay, if I want an index back here, Okay, I could just create, here's a new list, A, B, C, D. I'm going to assign it to original 1 index. And notice, when we first defined original 1 way back here, I said the index is DCAB, where D corresponds to 0.4 and C corresponds to 0.3 and A corresponds to 0.1. So this is the danger of just creating new objects and assigning them to the index, is that Python's not going to do any kind of check. The only thing that Python checks is the length of this index object thing that you're giving me. Is it the same length as this series? Okay, and if it matches, then Python says, okay, we'll take it. And over here, it doesn't care. I say A, B, C, D. So these are totally different, right? The A is now 1.4. This used to be D, and then B is now 2.3, and this used to be C. Python doesn't know, it doesn't care. It just says, okay, this is the index you've given me. Here we go. And so this is a double-edged sword. But this is kind of how R works as well, right? You can just kind of take a column and do stuff with it and just kind of C-bind it and things like that. So, it's not going to stop you from, hurting yourself, but you got to be a little bit careful, right? So, okay, so index A is 1.4, square bracket 0 is 1.4. If you do give it, so again, the one thing it does check is the length of the thing that you're trying to assign to the index. Is it the appropriate length? And if it's not, so here I have 1, 2, 3, 4, 5, then we get back an error, okay? And we get and it's helpful. It says length mismatch, okay? A lot of times these messages are scary, but yeah, a little bit of a clue here, length mismatch, and we go, oh yeah, you know what? I tried to give it 5 values and there's only 4 values in the series, okay? And same thing for data frames. Data frames have an index, and just like indexes of a series, you can take a new object and just assign it to where this is, okay? So that is helpful. Being able to kind of manipulate isn't the right word, but just create new things and creating, changing what the index of your series or data frame can be useful. A lot of these things in Python are powered by the index, or I don't know about powered, but just they take into account the index of the series or data frame before doing any kind of computations. Okay, let me give you your first view quiz answer. The first one today is D as in dog. Is it available? Okay. Sometimes I forget to publish. Okay, there is something called re-indexing, and I tried to put in bold. Do not confuse re-indexing with just creating a new index for a data frame object. So sometimes what you need to do is just create a new object and assign it to be your data frame, and other times you need to re-index. What re-indexing does is it takes an existing pandas object like a series or a data frame, and it creates a new pandas object that conforms to the specified index. All right, so here I'm going to recreate original 1. Again, it's already in the order 1.4, 2.3, 3.1, 4.2, where the value after the decimal point corresponds to the index value. So 0.4 is D and 0.3 is C, and so on and so forth. So there we go. All right, so here I'm going to take original 1 and I'm going to re-index it, okay? And I'm going to re-index this using the index A, B, C, D, and E. And what this is going to do is it's going to take this object, original, and it's going to conform it to this index, A, B, C, D, and E. So it's going to put A to the top, 3.1 at the top, then B, and then we're asking for an index E. So what is it going to do? It just throws in a nan, okay? So it says, okay, well, I've conformed this in that basically it rearranges the rows to kind of match this, and when it couldn't find the value, it throws in a missing value, a nan. All right. And if you want, you can specify the optional argument, fill value, and it does that. Okay, and now it puts a 0 in there. So I think that's expected. I think this kind of behaves the way we would expect. Okay, let me show you something that might be, perhaps like, where you can see this could be useful. So imagine having a time series where you start off at 0, or time 0, and then you got time 1, time 2, time 3, time 4, time 6, time 7, so on and so forth, right? You have these increments every day, something is going on. And perhaps you've actually only recorded like the times in which an event takes place. So you might say, okay, something happened on day 3, the color changed from blue to purple. And then something happened on day 6 where we went from purple to yellow. So what we can do is we can take this and we can re-index, okay? And here it says, okay, we got 0 is blue, and because we re-indexed it to a range 9, it goes 0 through 8, and it kind of matched up where we have values, and it filled in nans, okay? I could specify a fill value, and we will have put in the same constant for all the nans, but we have a couple fill methods, and one is forward fill, okay? And so when you re-index, you can forward fill, and basically instead of nans, it takes the previous value and it fills it forward until it encounters a new one. So it's going to go blue, 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 and then at purple it pushes the purple forward, and then at yellow it pushes the yellow forward. Okay, you have the basically the same thing, but going in the opposite direction, and this is backfilling. And so so here, if we just re-indexed, we would have nans at the end, and so we don't have anything to fill backwards from row 8, okay, but from row 6 back to 5 and 4, we can fill in backwards yellow, and we can fill purple backwards, and blue has nowhere to fill in, so this is what you end up getting. Okay, so that's forward filling and backward filling. This is especially useful, again, for time series type things, where you might want to take your current value and push it forward until at a time there was a change was recorded. Okay. All right. So here is when we're working with kind of time objects. So there's a few interesting index creating functions, and one is the date range. Huh? The McRib is back. Oh, look at that. Okay. Oh, somehow this shrank. Oh, look at that. I can resize my, I didn't even know that. Okay. Okay, date range. Well, let's see. What do we have? Okay, the date range documentation. There is some examples of how to create date ranges. And so, so make sure if you're going to use this to read the help. Okay, but here's just a few examples. We'll start with January 1st, 2010, period 6, frequency D for daily. And so what do we get? We get January 1, January 2, January 3, 4, 5, and 6. Okay, exactly, I think, what we expected. Let me see. I think I can do W, all right? And this will, I guess it starts January 3rd, and I guess we're looking at Sunday, okay? And then it goes 10th, 17th, 24th, 31, February 7th. You can do M for monthly, and for, I guess, we're looking at the end of the month, January 31, February 28th, March 31, April 30th, so on and so forth. And again, all of the kind of the options you have frequencies. Okay, here for a list of frequency aliases. Business, CDWM, semi-month, business month, custom business month, month start. Okay, well, these are, man, business is weird. Okay, now I guess it's just like Saturdays and Sundays don't count type of thing, but I don't know if they factor in like holidays and stuff, right? So that's like very culture specific. So so I'm not 100% sure, and so maybe that's where the custom business comes in. But anyway, you have a bunch of these kinds of different things available. Yeah, so custom business might be like, oh, you know what, fourth Thursday of November is a holiday, right? Or yeah, at least in the U.S., that's Thanksgiving. Or I don't know, other nations, I guess they go to work that day, you know. Friday after Thanksgiving is a federal holiday, right? That is, I don't know, so Thursday and Friday are, what do we call, I mean, we call it Black Friday because you go shopping and stuff, but is that what it's called? Federally? I don't think so, right? I don't know. Okay. Well, I'm glad we get it off. What was I talking? Okay, date frequency index. Okay, so you get a date time index. All right, so here, so here I'm creating a index of prices. I guess we're keeping track of some price, and I guess this fluctuates every day or something. I don't know. So imagine, yeah, whatever, stock prices or something. Okay, so let's, what did I do? Did I do the same thing? Create date frame. Oh, I must have just accidentally duplicated this row. Okay, sorry. We'll delete that. All right, so here is a second date range. So this one starts a few days before December 29th of 2009, and it ends January 7th of 2010, whereas, you know, we originally started January 1 and ended January 6th. And so if I just do re-index, we get a bunch of nans, okay? A bunch of nans here. I can say, let's backfill, and it will take values and fill them backwards. So the 100 fills backwards, like this. Now notice this nan does not get filled in backwards, okay? Because this nan, this missing value, was part of the original data set, okay? So the backfill only fills in missing values if the missing values are kind of induced or created by the re-indexing process, and it's not going to override any originally missing values. So because this value is originally missing in the original data, it's not going to backfill and take this 100 and move it backwards, okay? And similarly, if I forward fill, okay, it doesn't fill that in, and it just fills in kind of missing values that were created by the indexing things, okay? So re-index and .loc actually have similar values, okay? And this is actually .loc square brackets, not parentheses. That's a common mistake. is so many other things use parentheses, and .loc actually uses square brackets. Okay, so here's our data frame, and if I say re-index to ABCD, okay, it will do that, and .loc will do the same. Okay, ABCD. If you the difference happens is if you say re-index and you give it values that don't exist, then re-index will induce missing values, whereas .location will complain or will error out and say, hey, I can't locate this this location. There's no location E as far as the data. So you're going to get a key error that says E is not in the index. Okay, I gave you one answer already. I'll give you your second one. Second one is C. C as in, I don't know, Canada, cat, car, column. I'm gonna be here all day. All right, you want to delete a row? No problem. Or delete a column. So here's a data frame, columns A, B, C, D, rows X, Y, Z. All right, and you specify them just by these are basically index objects. The index is the row names. Columns is also an index. Okay, like I can. What is df.columns? Right, it's an index object. Just applies to the columns. All right, so here you just say, hey, get rid of these columns, or get rid of these rows, sorry, df.drop, okay? And you can say df.drop columns B and C to specify. So default is axis 0, which will be the rows. You can say, all right, get rid of the columns, which will be axis 1, okay? If I didn't specify axis 1, okay, then it's going to complain. It's going to look for B and C, just kind of like dot location. It's going to say, I can't find B and C. All right, it comes back with a lot of text, but usually the very last line, the key error itself, is usually most helpful. Just because when you try to read this traceback, it's like, oh, it's happening in pandas core base generic.py, right? So this is all kind of tracing back the argument, the command through all of the different files that exist in the pandas package where this command is actually running. And so usually you look at your first line of code and then the final kind of key error. And if you can make sense of it, then great. But here we'll specify axis 1 and we'll drop those columns. Now, as far as this goes, when you do this, df remains unchanged. If you want to actually change it, you can set this argument in place equals true, and it will make this modification in place. And so after I run old habits, okay, capital T lowercase RUE, when you do this in place equals true, it does modify the data frame. It does modify the data frame. So, so just something to be aware of. Let me go back and recreate my data frame in case I do want to make use of it later. All right. So so this is one of the great things about pandas is that it will always align your data before doing any kind of arithmetic. Okay, so here I've made two series. A is 7.3. So here we got A, C, D, E. We have no B in this series. And then over here I have A, C, E, F, G. So we have no D, but we do have F and G here. Okay, and so if I put these two together, we'll get A, C, D, E, F, G, right? So it sorts them by index and it matches them up and it says, oh, you know what, series 2 didn't have a D and series 1 doesn't have F and G, okay? Now you don't actually have to create the data frame. You can just take the two series 1, these 4 values, and series 2, these 5 values, and we're gonna add them. Okay, what do you think is gonna happen? We're gonna get a new series and we're going to get the result of adding these two things together after the indexes have been aligned. So it takes the A's and it does 7.3 minus 2.1. It takes the C's, 2.5 and 3.6. And the D, which is 3.4, gets matched up with a nan, and it says, okay, well, we couldn't do that. E, these matched up, and we get a 0, and here we have a nan and a nan, and it can't do those, and so it returns nan there. Okay, so it always lines them up. It doesn't, so if you did something like this in R, what would it do? It doesn't have a series things, right? You have two vectors, and it would just do the 7.3 and the minus 2.1, the 2. This value, the second value and the second value, third value and the third value, fourth value and the fourth value, And then R does the weird thing of recycling, and it starts back at the 7.3 and matches it up to the 3.1, and it'll say, I did this. It gives you a warning. It says the length is not a multiple of the shorter, the longer is not a multiple of the shorter, but it just matches it, not taking into account like their index or anything like that, because that doesn't exist. Same thing, there's a method called s.add, and it gives you the same results. The reason why you might want to do s1.add s2 rather than s1 plus s2 is I think you can do s1 slash nan add, dot nan add, I think. Oh no. What is it? NumPy series nan add. NumPy.add. Oh, man. Okay, wait, man. Maybe I'm mistaken. All right, I gotta remember. Oh, okay. Sorry, I'm thinking sum and not add. I'm just being silly. Okay, so if you do add with add, you can give it a fill value, right? So if you do say subtract. And this also works with add. You can give it a fill value, and so if it's missing something, you're just gonna fill in a 0, right? So for D, we're gonna do 3.4 minus 0, and for F, we're gonna do 0 minus 4, and G, we're gonna do 0 minus 3.1. So yes, if you wanted to do an add, you can do s1.add s2, and then you do fill value equals 0, or whatever else you want to do, and it will add. It will throw zeros in here so that you can do the add rather than getting nans. Okay. Whereas if you use the plus operator, you only have it's going to give you the nans. Okay. So if you do dot add, you have the option of specifying a fill value. Okay, same thing with a subtract. So it's going to do S1 minus S2. Now sometimes you want to do S2 minus S1. So you can do S2 subtract S1, or you can also do right-hand side subtract. And so you do S1 R sub S2, and basically it means start with S2 and subtract off S1. So start with the S2 on the right-hand side and then subtract off the left-hand side. So that's R sub. Basically just the negative version of S1.sub, right? So these end up being negatives. Same thing with multiply. You have the star operator, which will multiply things, and then you also have the dot multiply object, or dot multiply method, which you can specify a fill value. So for multiply, it makes sense for fill value to be 1, but again, you use whatever you want, okay? Data frames. Similar, so here I've got columns B, C, and D, and then rows Ohio, Texas, Colorado, and here I got columns B, D, and E, and rows Utah, Ohio, Texas, and Oregon. And if you take the two things, it's going to match them up and fill in nans. So actually there's only 4 values that kind of match up. We have B and D for Ohio, and B and D for Texas. But we have no match for C and no match for Colorado, no match for Utah or Oregon. So we get, kind of a lot of nan values here, which maybe that's exactly what you want. And if it's not, you can specify, instead of doing plus, you can do dot add and specify a fill value or something. And so now the only thing that's truly missing is Oregon and C, Utah and C, and Colorado and E, and those just don't exist anywhere in the entire data set there, okay? And then so here are all of kind of the different operations you can do, add and subtract, and the right-hand side, add and subtract and multiply and divide. And I'm not I'm not quite sure what right-hand add and right-hand, how those differ, but I don't know. I'm trying to think of an example where add and right-hand add would be different. I can't think of one off the top of my head, but they do exist for something. And there's probably some case that I'm not thinking of where it does make a difference. Okay. Summary statistics, this is very important. So if you want to take the sum of a column, you want to take the mean of a column, you want to do something like that. Well, by default, it's going to work across columns and it's going to skip missing values. Okay, so if I do df.sum, it's going to take column 1, sum them up, it's going to skip the missing values. Same thing with column 2, yeah?
I think for add, like if you're adding strings, it would make a difference, I guess.
Oh, it would. Yeah, okay. Adding strings. All right. So that's sum. You can specify axis equals 1. Okay, so again, what it does, it's going to sum across whatever axis. By default, axis is 0, so it's going to sum across the rows. It's going to collapse the rows down into 1. If you do sum axis equals 1 would be the columns, and it would collapse the columns into 1. Okay, so we're going to have now rows A, B, C, D, E, F, G, and these the columns get collapsed into 1, and so we get 1.56, minus 4.5, stuff like this. Okay. If you say skip NA is false, then it's going to say, well, here are missing values, and I can't do it. The mean calculates the mean. You can specify axis 1 to get row means. There's other things. You can ask for the minimum, and you can also ask for the ID of the minimum. Which row has the minimum value? And it's if there are multiple, like if there's ties for the minimum value, it's going to give you its first encounter. So here, if you look at, what is column 1's minimum value? The column 1's minimum value is 1.5, and it exists in row A and row D, but it's going to just give it its first encounter, which is going to be row A. Okay, what's the minimum value for column 2? Negative 4.5, and that's going to be correspond to row B. So these are other kind of values that or other methods that are available as far as summary stats go. So you can, mean and median sum, those I think we're all kind of expecting, but you can also get the count. So all of these things take multiple values and return one value, right? The variance, standard deviation, the product, the quantile takes multiple values, and you say, I want the 50th quantile, which would be the median, or I want the 75th, basically percentile, things like that. All right, let me give you your last view quiz answer, which is A. A as an apple. A as an apple. Okay. You can ask for unique values. Okay, so here is column 1. I want the unique values in column 1, and it gives them in the order that they are encountered, just counting up 1.5, then 6, then the nan, and then 4.0. Same thing. And so here, you can just reference a column just by doing dot its name, as long as, you don't have spaces or anything like that. And if you didn't, you'd have to use something like this, right? So you can specify a column using square brackets, or whoops. Okay, so you can see you have a few ways to go about this. Okay, if you do dot unique, not on a series but in the entire thing, it's going to complain. Okay, so unique can only be applied to a series or a column in a data frame. You can also ask for the number of unique, which will be non-missing unique values. So nan doesn't get counted. So for df.1.number of unique, it's going to say there's 3 values. You can also ask for value counts, which will give you a table of how many times each value appears. we have an is in operator, and it will give you back trues and falses if the value there is one of whatever, you give it a list of something. So you can say, hey, is. So this is useful if you want to kind of check, like, is it one of this or this, okay? Or this, right? If you have like 3 different things that you want to check for, you can say, is the state name one of, California, Oregon or Washington, West Coast states. And so you can say, df.state.isin, and then you give it a list, California, Oregon, Washington, or something like that. Okay. If you want to use kind of classical Boolean operators, you'd have to use the bitwise OR, all right? And you can get kind of the same thing back. I would recommend is in over doing something like this. This is not wrong. It'll give you the same, but this is also easier. And then if you want to, once you have this, you can use that to kind of filter out your rows. So you use df.location and then your kind of Boolean criteria, and it will give you those rows where column 1 is 1.5 or 4.0. Okay, so you just use the Boolean thing to do that. Missing values, I'm going to go through this quickly, but there is .drop NA, so remove any row that has a missing value, so anything that's not complete. Here you can do drop NA how equals all, and it will only remove rows where it's completely missing. So it will only drop this row, right, where all the values are missing. Okay. And then you can also use this not null operator for one of the columns, right? So here we can say drop any row where column 2, or only keep the rows where column 2 is not null, if you only want to specify something like that. Okay. We have a few options for filling in missing values, and I guess I'll let you guys kind of go through this. And they basically work exactly as you expect them. You can specify different values for each column. So you can say for column 1, fill in 1,000 for missing values, and for column 2, fill in 0 for the missing values, so on and so forth. You can fill in missing values using the mean of each column, okay? And also you can fill in missing values using backfill or something like that, okay? So, so these are, options and stuff that you can do. Okay, well, I think I gave you all your answers, right? All right, so we'll end here for today. We'll see you on Wednesday. Have a great rest of your day.